The periodic table is a table that organises the elements by their atomic number, electronic configuration, and chemical properties. But even before any table of elements was formed, scientists were observing curious patterns amongst the known elements. Over the years, as more and more elements have been discovered, similarities in the way elements reacted with different things were observed. For example, some gases are completely unreactive with everything, while some metals have vigorous reactions with water. Properties like these allowed elements to be grouped together. In the 1800s, not a lot was known about the elements. Protons, neutrons, and electrons weren't even an idea. So the only logical way to order the elements was by order of their atomic mass. In 1817, one of the first patterns amongst the known elements was observed. Johann Wolfgang Dobryna noticed he could form groups of 3 with elements exhibiting similar properties. He termed these groups triads. An example of one of these triads was lithium, sodium, and potassium. The interesting characteristic of triads was that when they were placed in order of their atomic mass, the middle element always had an atomic mass which was an average, or very close to an average of the other 2 elements in the triad. 50 years later came Newland's octaves. Newland noticed that when the elements are arranged in order of their atomic weight, every 8th element had similar properties. So he listed some of the known elements in rows of 7. His pattern only worked up to a certain point. It broke down on the 3rd row, with the transition metals like iron, copper, and zinc causing a massive flaw in his theory. His theory was met with ridicule, but he was close. The problem with his arrangement was that he left no gaps. Not all the elements had been discovered yet. In fact, none of the group 0 elements had been discovered at all, and many of the elements had been assigned incorrect atomic weights. He had also not predicted the complex nature of elements. In 1867, Dmitri Mendeleev formed the first table of elements. He anticipated complexities and missing elements and transformed Newland's octave into a plausible arrangement. He even went as far as to change atomic weights of known elements so that they would fit into his arrangement. His table allowed him to look at the elements and from there predict the properties of those missing elements. And as more and more elements were discovered, his tables went through many redrafts. One of the gaps in Mendeleev's table was found below aluminium. He predicted the properties of this mystery element and that it would have an atomic weight of around 68. In 1867, gallium was discovered, the mystery element. Mendeleev's predicted properties matched this new element's property almost exactly, marking a turning point in the world of chemistry. His table started to become widely accepted. There were still a few problems with Mendeleev's periodic table. When Mendeleev began drawing up the periodic table, the noble gases hadn't been discovered yet. When argon was discovered, it didn't fit into Mendeleev's table. It was put into a new group, group 0, and over the next few years, other members of this group were discovered. Other problems with ordering the atomic weight also caused issues. These problems have been solved in the modern version of the periodic table we use today, giving us an excellent resource to understand the elements and all that we and our surroundings are made of.